Hello Repton, welcome to another STEM challenge. Now today we're going to have a go at creating a wind-powered boat. You are going to need some materials for this. Although you can get creative and use lots of different types of materials, there are certainly some that I would recommend. Now to do this in the way that I'm going to explain, you'll need some sort of a plastic container. You'll need a sharp knife as well, but please do get an adult to help you when you need the knife. Some balloons, drinking straw, sticky tape, an elastic band, some scissors, some sort of blue tack, and then something to put your boat in. So, a swimming pool or a bath full of water. First, you're going to use the knife to make a small hole in one end of your container. Now it needs to be just big enough for your straw to fit through. Okay, this is the part that you'll probably need an adult to help you with. Now it might be a knife that you use. I have to admit when I did it I just used a screwdriver actually to poke a hole through. So up to you how you do it, but please be safe with this part. You then need to cut your straw in half. You want to attach the balloon to one end of it, and this is the point where you're going to use the elastic band, because you will need to tie it around the balloon and the straw. Now, if you've not got elastic bands, then string certainly works as well. Elastic band is slightly better though. It needs to be very secure. Okay, so when you blow up the balloon, the air doesn't all escape around the seal. So I would suggest that you use sticky tape. Once you've done that, then use sticky tape over it to make sure that you've got no air gaps whatsoever. What you've created, you then need to feed through the hole that you made previously in your container. Right, the blue tack is also to hold things in place. Okay, so this time I put blue tack on the inside and on the outside. You can use plasticine for this. If you haven't got those, then you could potentially use sellotape as well. There's lots of different things, as I said at the beginning, that you could potentially use. You just need to have a go at using something to reduce the amount of air that can escape and to hold it in place. Now, once it's there, you have essentially your balloon-powered boat ready for the water. If you blow up your balloon through the straw and pinch the straw so the air doesn't escape before you place it onto the water. You then place it onto the water, let go, and the air forced out through the straw will propel the boat forward. Now that's the fun bit, that's the arts and crafts part of it. Where does the science come into this? Right, the science comes into this in that what I would like you to do is to think about how to extend this experiment. I've shown you one way of making one of these boats, but how many ways can you think of? Can you find the most efficient way? If you look at the three examples on the right-hand side here, someone's made one just with a milk carton by the looks of it. One person has used and shaped a piece of polystyrene. Another child has placed a balloon and the straw through the bottom of a sponge and used that. Which one of these do you think would work the most? Do you think the sponge would be best? Or do you think it would absorb lots of water and therefore be quite slow? You might want to think about how to get this to go into a straight line as well. So could you incorporate some sort of a rudder? Maybe you are going to shape this, making it with silver foil instead. Perhaps you're going to try a different approach and you're going to have the same boat, but you're going to play around with different balloons. You can get long balloons, round balloons, all sorts of shapes these days. Maybe you try some different types of balloon. Fundamentally, this is a bit of fun to make a boat. I have to admit, I had a great deal of fun actually having a go at doing this. But when you think about the science behind it, we call this a STEM task because you're thinking about how to make it dynamic in the water, how to make it go in a straight line. So there's problems that you need to have a go at solving. Good luck, and please do let your science teachers know if you have a go at this. We'll be happy to share in your findings, and I'm sure we'll also love to give you some merits and credits for your efforts. Thank you very much. Good luck. Hope you enjoy it.